Students, so last day we tried for refraction. Okay, so that topic I am going to repeat again for you. So now I am going to start. Your next topic is refraction. So you know about reflection. Now we are going to study about the refraction. That one also you have studied before. Now what is refraction? Refraction means the bending of light when they travel one optical medium to another optical medium having different density. Now, so we know that light always travel in a straight line, but in this case, the light will bend from its original path depending on the density of the medium. Now, another question is comes here: what is density of the medium? Correct. So, medium there is two types, whether it will be rarer or otherwise. Which one? Rarer. Another is, you know already. You tell. One is rarer medium. Another is denser medium. Yes, another is denser medium. So now how will you differentiate between the rarer medium and the denser medium? In rarer medium, the speed or velocity, speed of light increases. Correct. In rarer medium, light can travel very fast. Whereas in case of denser medium, the speed of light decreases. That means it becomes slow. That means in rarer medium, light becomes faster, and in denser medium, light becomes slower. Now, how will you find out? How will you measure that which one is denser or rarer medium? For example, suppose you are having water, air. You can compare between them. That water will be denser medium and air will be rarer medium. Now, here also you can measure by using refracting index. By using the term refractive index, you can measure the density of the medium. So that refracting index is nothing but defined as C by V. What do you mean C by V? C is the speed of light in air, or you can write vacuum. Whereas V is the speed of light in that medium. So, as I told, if you see here, as B is their reciprocal, that means if B increases, mu will decrease. That means if refracting index decreases, that means what? Speed of light will be more. Whereas if B also decreases, that means speed of light decreases, refracting index will be more. Clear? So, by seeing the value of refracting index, you can find out. And always remember, if you want to find out the speed of the light, that means refractive index is air, it will be C by C, you will get 1. That means your refractive index will be more than 1. If it is more than 1, that means it's how much will increase? More than the value more increase, the speed of light will decrease, your medium will be denser medium. Clear? Now, next one, you already know what is refraction. Already I told. Now you see that what will happen when the light flows from one optical dense medium to another medium. Let's see. So consider this one is first medium mu1, mu2, where mu2 is greater than mu1. That means this one is rarer medium and this one is denser medium. So this one the normal. So now if light ray comes from rarer medium to denser medium, they're supposed to go in that way, but it will bend towards the normal. It will bend towards the normal. That means you can find out here your I is greater than R. That means angle of incidence is greater than angle of refraction. Same. Now, if mu is first one is denser medium and second one is rarer medium, here I is less than R. That means it bends away from, this is the normal, it bends away from the normal. So, that first case, when it is come from rarer medium to denser medium, the light ray, it comes towards the, or it bends towards the normal, whereas it comes from denser medium to rarer medium, it bends away from the normal. Now, there is another case which is called no refraction. That means no bending will be there. In that case, if mu1 is not equal to mu2, that means both the refractive index are not same. If light ray falls like perpendicularly, that means I equal to 0. In that case, R also will be 0. There will be no refraction. And the second case, if both the refractive index are same, then also there will be no bending. I will be equal to R. This is the case of no bending. So, now these are the cases of refraction. Now, what is the law? You know that in reflection of light also we have studied about the law. Now we are going to study the law of refraction. So, as we know, first law, incidence ray refracted ray normal, they lies in same plane. Okay, as usual. Now, what is the second one? So, in case of reflection, we founded that I equal to R. In case of reflection, we founded that angle of incidence equal to angle of refraction. But here we already saw that first two cases I is not equal to R. When it is coming from rarer medium to denser medium, I is greater than R. When it is coming from denser to rarer medium, I is less than R. So, what is the relation between them? The relation is given by the Snell's law. That is given by the Snell's law. So, for that, you can see different. If you change your I, first one is I1, R1, second case I2, R2. So, how will be the relation between them? Because I and R1 will not be same. So, if you change the angle of incidence, the angle of refraction also changing. So, that one is given by Snell's law, that sine I1 by sine R1 equal to sine I2 by sine R2 equal to sine I3 by sine R3 is always constant. Okay, that is always constant, and that constant is equal to the ratio of their, which one? Incidence, reflective index. That means you can write down sine I by sine R is given mu 2 by mu 1. Or to remember, by cross multiplication you can write down mu sin I equal to mu2 sin R2 or sin R. You can see. So that means how will remember mu1 into sin I and mu2 into sin R. In that way you can remember the law of reflection. Now let's find out some relation. Now what is mu C by V? Here we will write V is the velocity of the second medium, or is mu1 C by V2. V1, it is the velocity in the first medium. If you cut, you can find out V1 by V2. There is one relation. Another relation we know that V equal to lambda F. So these two components, they depend on speed or they depend on the medium. This one is does not depend. So here if you write lambda 1 F, lambda 2 F, this one cancel. So you can find out mu 2 by mu 1 equal to V1 by V2 equal to lambda 1 by lambda 2. This one is a relation. Another is you are having principle of reversibility. What is principle of reversibility? If a light comes from one medium to another medium, if you keep here one mirror, then if you keep in perpendicularly, the same path it will follow and it will go back. That means mu 2 by mu 1, you have to write in this case 1 mu 2. We used to read this one mu 2 upon mu 1. If you write in reversibility, it will become 2 mu 1. By using this formula, the numericals are there. We will discuss later. So this is your reflections and there are some relations. Now we are going to study about the relation n2 by n1 equal to d by d dash, where d by d dash is real depth by apparent depth. Imagine what denser medium is there. There is your object, and you are going to keep your eyes here. You are going to see the object. Now, as it is, and remember this one is mu 2, this one is, or you can write this one is n2 and n1, where n1 is the refractive index of the medium of whatever this one glass slab or this one, and this one is air. Now, n2 is always greater than n1. Now, as we know, it is coming from denser medium to rarer medium, it will bend away. That means the eyes will see this object here in this place. Now, this one is called as D, which is the real depth, and this distance is called as D dash, that is called apparent depth. Now we are going to find the relation between them. This is your I, this one is your R. Now you see this one and this one, they are related. You know that there means alternate angle. This one is I mean, this one also I. If this one is R, this one also R. How? You know, by geometry you know this one. So now we are going to find the value. Let's consider this is X. Now, as we know, the rays are paraxial ray. They are paraxial ray. They are much closer. As they are much closer, you can write down sin I almost equal to I almost equal to tan I, and sin R almost equal to R, you can write tan R. So what is your relation? N2 by N1, N2 into, it is here N2 into N2 will be sin I sin R by Snell's law. Now what is the value of sin R? You can see here sin R value is tan R, sin I value also tan I. Now you see this diagram, you can find out perpendicular by base. That means x by d dash equal to x by d, x cancel, you can find out d by d dash. So here the relation n2 by n1 equal to d by d dash. That means the ratio of refracting index is the ratio of real depth by apparent depth. Now the next topic is refraction through glass slab, and here we are going to find the shift S equal to T into mu 1 minus 1 by mu. This relation we are going to find. Now this is your glass slab. There is one object. Now this is the first surface, second surface. Just consider the first surface. If the light comes here, this one we will consider mu equal to 1. Here mu equal to 1. That means it is coming from air, glass, again air. So let's consider the thickness of the glass slab is T. Now, if in the first surface, when it is coming air to glass, that means it's supposed to go in that way. What will happen? Again, it is coming rarer medium to denser medium. If you see from inside of the glass slab, that means rarer medium to denser medium, you see that it bends. It bends towards the normal. That means your eyes will see the light is coming from here. That means I am writing I initial. Clear? So let's see what is happening here. As our formula is n2 by n1 equal to d by d dash. Now, what is n2? N2 is your mu. So it is coming from first medium to second medium. So n2 by n1 equal to d by d dash. So what is your n1? What is your d? Let's consider this distance as x, and you are going to find the distance d dash. This is the distance. So you remember, we always find out the real depth from the surface, not from here. We are going to find the surface. As it is reflecting from the first surface, we will find out the distance from the first surface. Clear? So, as it is coming from first medium to second medium, that means your x by d dash, by cross multiplication you will get d dash equal to mu x. You are going to find the distance. So, this distance is mu x from the slab. Now, this light will again reflect here. As it is coming from denser to rarer medium, now it will bend away from the normal. That means the eye will see light is coming from here. Now again for seconds, this is the first surface. Now for the second surface, again formula if you use, so what is your n1? Now your this one will be mu coming from second to first. That means mu by 1 equal to d. Let's find out the distance from the second surface. So from the second surface, now this is your object. Now this one will become your object. The distance is t plus mu x. T plus mu x. Then you can find out d dash equal to t plus mu x by mu. Now this is your shift. If you consider this one is p, this one is your shift from the initial position to final position. Now how we are going to find your shift? Your shift you can find out. Your shift you can find out what is the total distance OP minus IFP. So this distance is given how much? So OP is OP. What is your distance? X plus t, because this one is t, this one is x. X plus t minus t plus mu x by mu. If you take LCM, mu x plus mu t minus t minus mu x, this one cancel. You take t common, by dividing you will get 1 minus. If you take t common, you will get 1 minus 1 by mu. So this is the relation. So now this mu 1 and mu, because we are considering here air, that's why this value is 1, and this one glass slab we are considering mu. So the original formula will become shift equal to T into 1 minus mu of the surrounding medium divided by mu of the slab. This is the relation. So your shift depend upon the thickness of the slab, the refractive index of the surrounding, as well as the refracting index of the slab. So if S is positive, the shift is positive, that means it shifted to the direction of incidence ray. That means this is the direction of incidence ray, so it shifted to the direction of incidence ray. If S become negative, it will shift opposite direction of the incidence ray. So this is the refraction through glass slab. The last topic you know already. For today I am going to teach you, that is total internal reflection. See, when a light travels from denser medium to rarer medium, the first consideration is it should travel from denser medium to rarer medium. When you send, it will bend away. Again, you increase your angle of incidence. You'll find that it is going along the surface of sun. That means your R becomes 90 degree. So this angle is called as critical angle. Now, if you go beyond that critical angle, there will be no refraction. It will directly reflect back. This is called as total internal reflection. That means when your I will be greater than IC, that means a light if travels from denser medium to rarer medium and it fall more than critical angle, that is called critical angle, there will be no refraction. The total light will be reflect back. That is called as total internal reflection. So again, if you want to write, so here you can write N2 into IC sin IC. That means N2 sin IC equal to N1 sin 90 for the condition. We can find out N2 by N1 equal to sin 90 by sin IC. That means sin 90 value is 1. We can write N1 by N2 equal to sin IC. There is a relation. So this is the relation from Snell's law. So this is the topic we have learned before, but still I am going to memorize you so that you will be able to study the later chapter. So what have we studied today? What is refraction? What is the law? What is refracting index? The diagrams, ray diagrams, then law of reflection, then through glass tube, then real depth, apparent depth, now total internal reflection. So these are the topic you memorize. Next class I will discuss more. Thank you.